Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss alpha particle scattering, Rutherford's atomic model and its limitations. Let's begin. Atom, which is the smallest particle of matter and that participate in all types of chemical reactions. First of all, the scientist J.J. Thomson came into picture and proposed the model of an atom. According to him, in an atom has positively charged matter in which electrons were embedded. In that sphere, that substance positively charged matter in which the negative charge electrons are embedded. You can point out that sphere corresponding to a watermelon. In case of watermelon, the substance in that of watermelon treated as positively charged matter, whereas the seeds called as electrons. According to J.J. Thomson's atomic model, in an atom, positively charged matter in which electrons are embedded. Rutherford, one of the student of J.J. Thomson, and he tried to perform an experiment to showcase what exactly be the model of an atom. To verify this, his student Rutherford, student of J.J. Thomson, Rutherford performed the very famous alpha particle scattering. So, what is alpha particle? Alpha particle is a positively charged particle having mass equal to 4 times the mass of hydrogen in an atom and positive charge equal to twice the charge of a proton. The alpha particle, we write alpha particle as doubly charged helium nucleus 2He4, 4 times the mass of hydrogen and positive charge equal to twice the charge of proton. 2He4 is nothing but alpha particle. Then come to the construction, or we can say experimental arrangement for that alpha particle scattering. Alpha particles from radioactive source radium, which is contained in a lead cavity, are collimated into a narrow beam with the help of a lead plate having a narrow slit. This is a lead cavity. This is lead cavity. In that lead cavity, we place radioactive substance so that radioactive substance emit radiations, and that radiation passed through lead plate. That lead plate is designed in such a manner which culminated that radiation. Lead plate with slit. In that point, that is act as a slit, that radioactive substance emitted radiations in case that radiation contained alpha particle. So, alpha particles are passed through that lead plate slit. The narrow beam of alpha particles are made to fall on a gold foil, that gold foil about 10 to the power minus 7 meter thick, beyond which is placed a screen. That screen is coated with zinc sulphide. Here we place a gold foil the thin gold foil. Beyond that thin gold foil, we placed a screen. That screen is made up of zinc sulphide, zinc coated screen. When the alpha particles striking on that of zinc coated screen, the screen caused a teeny flash, means a bright spot we observe in case of that zinc coated screen, which could be viewed in our naked eye, and we can count what be the number of alpha particles striking on that zinc coated screen. The alpha particles, some are striking here, again some of the alpha particles are scattered and striking on that zinc sulphide screen, and tiny bright spot we notice in that zinc sulphide screen. These are light flash due to alpha particles. When alpha particles striking on that of zinc coated screen, we see light flash. These are the experimental setup by Rutherford. This is scattering of alpha particles. By using that experimental setup, he observed. From this experiment, some of the observations made by him. He observed most of the alpha particles were found to pass through the gold foil without any appreciable deflection. No deflection notice in case of most of the alpha particles, and these alpha particles without deflecting means no scattering. He noticed most of the alpha particles without deflecting passed. Another observation, in passing through that of gold foil, the different alpha particles undergo different amount of deflections, and a large number of alpha particles suffered fairly large deflections, and some of the alpha particles deflected at different angles, and some of the alpha particles deflected largely. Next observation, a very small number of alpha particles, that number 1 in around 20,000. If 20,000 number of alpha particles are passed, from this some are undeflected and some are highly deflected and some are totally not deflected. Around 20,000 of such alpha particles, only one he noticed deflected through 90 degree, and occasionally a particle went back along the direction from which it come to deviated through 180 degree. Look at figure. This is the nucleus. Till now nucleus is not observed. For our understanding, I say that is the nucleus, and this be the atom. Some of the alpha particles are passed undeviated, and some of the alpha particles deviated largely. Here we see out of 20,000, 1 deflected through 90 degree, means it is deflected through 90 degree, and out of which occasionally a particle went back in the same direction from which it came, that is 180 degree deflection. See, 180 degree deflection. Again come here, this is 180 degree deflection. That was the observation seen to Rutherford. This is atom, that is nucleus. These are alpha particles, that are scattered alpha particles, and these are incident alpha particles, This is the observations. By taking that observation, he conclude the atomic model that was named as Rutherford atomic model. Atom may be regarded as sphere, that sphere of diameter around 10 to the power minus 10 meter, and the whole of the positive charge and nearly whole of the mass of the atom is concentrated in the nucleus, having a diameter of about 10 to the power minus 14 meter. From that of experiment, as we say, most of the alpha particles were found to pass through the gold foil without any appreciable deflection. Therefore, it is seen that the atom has a lot of empty space in it. It has a lot of empty space in it. From that observation, we conclude it has a lot of empty space in it. In passing through the gold foil, the different alpha particles undergo different amount of deflection. A large number of alpha particles suffered fairly large deflections. So, alpha particle is positive charge and it is deflected, means positive charges are repelled with each other. So, he concluded from that concept, since the fast and heavy alpha particles could be deflected even through 180 degree, and the whole of the positive and nearly the entire mass of the atom is confined in an extremely small center core. So, it is named as nucleus. From these two observations, we see nucleus is the heavy and nearly teeny portion of the atom which is positively charged. Again, from these two observations, we conclude that point. By taking such observations, Rutherford proposed his atomic model. First atomic model, first point, atom may be regarded as a sphere of diameter 10 to the minus 10 meter, and the whole of the positive charge and nearly whole of the mass of the atom is concentrated in that of nucleus, and nucleus having diameter of about 10 to the power minus 14 meter. Basically, in Rutherford's atomic model or Rutherford's alpha scattering experiment, we are conclude about nucleus and the discovery of nucleus from that particular experiment. Next, the nucleus is surrounded by electrons. How these electrons are motion around that of nucleus? As we say, atom is electrically neutral, and the total positive charge on the nucleus is equal to the total negative charge on electrons of the atom. Since in that of nucleus, in that of center where it is positively charged, as atom is electrically neutral, therefore, whatever may be the amount of positive charge within that of nucleus, that much amount of electrons are revolving around that of nucleus. Next point, the electrons in the atom are revolving around the nucleus in various circular orbits, and the centripetal force is provided to the electrons by the electrostatic force of attraction between the electrons and the nucleus. That is the nucleus which is positive charge, electrons are revolving around that of nucleus due to that centripetal force or electrostatic force. This is positive charge, that one is negative charge, and these two are attracted with each other due to electrostatic force of attraction. Next, what be the limitations of Rutherford's atomic model? According to electromagnetic theory, a revolving electron should continuously emit energy, and hence the radius of its path should go on decreasing. Ultimately, it should fall into the nucleus. However, electrons revolve around the nucleus without falling in it. Hence, Rutherford atomic model cannot explain the stability of atom. Let you understand it. That is the nucleus, and electrons revolving around the nucleus. So, when electrons are revolved, so gradually the radius undergo decreasing, and finally that come to the nucleus and it is collapsed. But actually situation is that there will be no collapsing. That is why the stability of atom can't explain by Rutherford's atomic model. Next limitations. Rutherford model can't explain the line spectra of atoms like hydrogen. As we previously discussed, in case of hydrogen atom we see line spectra. The spectral line named as Balmer series, Lyman series, bracket, Pfund. These series we notice as an example of spectral series, because if Rutherford atom model is true, as electrons revolving around that of nucleus continuously, the electron can revolve in orbits of all possible radii, hence it should emit continuous energy spectrum. But actually hydrogen showcase line spectra. So, the spectrum point of view that the Rutherford atomic model fails to explain. So, here with the help of this video lecture we understand the concept of alpha particle scattering, what was J.J. Thomson's atomic model, and then it was confirmed by experimentally by Rutherford, and he see a new type of observation and proposed his atomic model. This is the experimental arrangement. From that experimental arrangement, some of the observations, and according to these observations some points are noted. By taking these observations, Rutherford proposed his atomic model named as Rutherford atom model. Basically that atomic model based upon nucleus, the discovery of nucleus due to this famous alpha particle scattering. And finally, the limitations of Rutherford's atomic model. Basically it does not explain the stability of atom and the spectrum as we notice in case of atom. So, with this useful and informative notes, let me wind up the session. Thank you.